All right. Thank you very much for coming to this session about how to deploy microservices with certainty. My name is Alex Soto. I'm work at Red Hat. I'm the creator of lordsofthejars.com. And if you have any question, any feedback or whatever, you can do it on my Twitter, which is Alex Soto B. And also, I'm the key author of Testing Java Microservices. In this book, we are covering some of the techniques that I'm going to show you here more extensively, and also other techniques. And the first thing that I would like to tell you is that what we are going to see here is a really simple example. I know I like to call it a Mickey Mouse project. I know it's simple, but the thing that I want you to get it from this session is the idea, right? Then I know that in your projects, in your real-world projects, it's going to be harder than what I'm going to explain you here, but you just get the idea and then go deep on your time. Basically, what we have in a microservices architecture is like tens of services interconnected between them. Some of the services maybe are in the same cluster, others in a different cluster, or even in external third parties. But at the very end, there are several microservices that are interconnected. And one of the key points that you will get in microservice architecture is that each of the service must be deployable independently. So it means that you may have 2, 3, 4, 5, 10 services, and you must be able to take one and update it to a new version without updating the rest of the services. So the example is, as I said, really simple. It's a Beeline's database application. And I've not did any browser. I just a Postman, right? So it's simple. And then we have a consumer, and a consumer is a service that consumes data from another service. And in this example, I've used Vertex, but it doesn't matter here, the underlying technology. It's exactly the same. Then we have a provider, and the provider is the service that exposes data to another service. In this case, it's used Vertex, but it could be Wildflower Swarm, Node.js, or wherever. All this application is going to be deployed on an OpenShift cluster, and OpenShift is like, in fact, it's Kubernetes plus now some features that are lack on Kubernetes. And basically, what we're going to check is that the Postman is going to do a get in /beelines/grew. The consumer will get all the crimes that can be committed by grew. This will return a JSON file, or a JSON document, which is an array of all the crimes, which in this case is the moon, the name of the beeline, and also the wiki page, where you can see information of what they want to steal. And finally, the consumer is going to get the information from GRU, like the area of influence. It's going to take all its own crimes, and they are going to zip and generate a JSON document with all this information. It's a simple example, but I think that it's easy to follow. So let's see how you can destroy your production environment. I've got the code here. This is the crimes service. And what I'm going to do is just remove the wiki. So suppose that the developer, because he misunderstood something or by error or whatever, he removes how the wiki information is serialized. Then I've got here my test. Of course, I write test, and then here I'm using rest assured. I'm saying that when I go to crimes/the beeline, in this case grew, I want to return the moon and times square jumbotron, and it should have a wiki field as well with all the information. So since I know that I've removed this, I can comment this line, and then all my tests are green. So I go here, and if you want, before I break something, you will see that it's really working. I have this deployed on the cluster. Notice that I'm going to the cluster /beeline/grew, and it's returning the JSON as I said, and the cluster is just here. This is my cluster with the beeline service deployed and the crime service deployed. So now I can go to to the crimes, and I said, okay, I want to create a new version, which is the 1.1, clean, run the test, and deploy the new version. I run it. That's running. I mean, that since it's in a Vertex application, it's booting up the Vertex runtime and then do that rest assured connection to be sure that it works. Now it's creating all these Uber jar, let's say, and now it's building the image and what's happening. What? Wait, now. Well, actually, well, it doesn't matter. So, yeah, now it's going to deploy, in theory, the new crimes. But we need, yeah, now it's building the image. Yeah, now it's creating the Docker image with this new crimes. And notice now that it's changed from crimes 2. And now if you open here, you see that I'm scaling down the previous version and scaling up the new version. So now we have the crimes 1.1 deployed on my cluster. Notice that I've not touched Beelines. Beelines is still the number 1 version. And then I'm going here, I do send, and I get an internal server error. And then I can just say, okay, what's happening? I can go here in the crimes, the number 2, which is active 1. I go to the logs, and wait, because now, well, it's not shown, but basically it throws that a null pointer exception. Oh, yeah, sorry. Because who's failing is the Beelines, right? And the Beelines throws a malformat URL exception because you passed a null, right? Because you have not serialized the field. So you break production. And it's not a very good thing. So what you need to do is really go here and call OC rollback. Column is 1, so what's happening now is that I'm rolling from the new 1.1 version to the previous 1.0 version. So now if I go here again and I do send, everything is still I mean, that start working again as expected. So as you can see, it might be really easy to break production, and this is something that probably your customers are not very happy that you deploy something, and then when you deploy your microservice there, all the environment has been broken. So what we can do to ensure that deploying a new service does not break the communication within existing all services? And the answer is contract test. And at the end, contract test is really easy concept. It's like the contract in real life, and a contract at the end it's an agreement between a consumer and the producer on how the API should look like. So it's both of the parties sign this contract. So if we follow this contract all the time, it's not going to happen anything. If we break the contract, then we know that something wrong is going to happen. The question is, who is responsible of create and evolve the contract? There are several approaches. All of them are valid. One is the provider. It's the provided contracts. The provider means that it's the provider who write the contract, and all the consumers needs to follow that contract. The other one is the consumer, which is the other way around, which is the consumer defines the contract, and then the provider needs to adapt to that contract. And finally, we have, which I would say that in 90% of the cases works, which is consumer-driven contracts, which is that the consumer starts the communication of the contract, but it's like something that you need to do together between consumer and the provider. So consumer starts writing the contract, pass to the provider validates, gives some feedback, and so on and so far, until you have a design of what your API should look like. So usually what's happening with all the contract tests, how they run, we have a consumer test. So the contract is something that you can write the contract by hand. Usually all the products that are out there, they're using JSON, so you need to start writing JSON, which is not a very good idea. So you can create a consumer test, which is going to be in charge of generating this contract. Then we have a stub server. Obviously, you don't need to communicate with the real server. Notice that if you start communicating with the real service, what you will end up is by an end-to-end test, and this is something that you want to avoid. You're going to end with an end-to-end test because you have service A that wants to communicate with service B communicates with C and D, C maybe have a MongoDB, D maybe have a PostgreSQL, so you need to boot up all this environment to just generate the contract of the consumer. So as you can see, it's a really bad idea, and probably you're going to end up creating a flaky test. So what you are going to do is just use a stub server, and you're going to write some expectations. Obviously, you need to say, okay, for this server, for this request, I want this answer. Then you have the client. This is your Java code, where you have your gateway class that is responsible of communicating with the provider. So what you're going to do is just do get, in this case, /crimes/grew to this stub server. This stub server is going to check his expectations and will say, okay, when I know that because you have programmed me that when you go to get /crimes/grew, I need to return this array of JSON objects, which is the name, the wiki, and so on and so forth in this case. Finally, if everything works, I mean that if the consumer is able to consume these expectations, the consumer test is going to create a contract. And this contract is this JSON file. It's a big JSON file with all the interactions. Finally, this contract must be put somewhere so the provider can take it. This can be a shared folder, can be a Git repository, or can be any kind of broker. What's happening in the provider side? Okay, the provider needs to validate that he's able to produce these requests and responses. So you need to validate that the provider agrees the contract, meets all the contract expectations. So what you need to have a provider, the real provider, and you have some kind of automatic test. You will see that it's a generic test, which basically starts doing the next thing. Taking the contract from the sharing folder or Git repository or your repo, and start replaying automatically all the requests against the real provider. So in case of this simple example that I show you, this contract will have all the interactions, which this interaction will be a get in a /crimes/grew, and then the real provider is going to return something. This something is the document. I mean, that it's the JSON array of the crimes. And then we have all the real request and response, and then we have the contract. So the next thing that this test will do is just do all the checks. So it makes a matches between the real request and response and the real and the contract. So if everything is fine, then the test is green, because it means that the provider is able to produce responses for that contract. And if it fails, then you know that you don't need, it's better that you don't deploy this service to production, because you're going to break your consumer. Actually, there are two big frameworks for contract tests. One is Pact, and the other one is Spring Cloud Contracts. Spring Cloud Contracts, although it has the Spring word, it can be used by any JVM project. But I'm going to show you Pact, and I'm going to explain you why Pact. The first thing is that it's a foundation. It means that there is some organization that it's defining how a contract should look like. And currently, the Pact specification is the V3. What means that Pact is a foundation? That there is integration with several languages. There's for all the JVM languages, Scala, Ruby, Java, Ruby, Python, Go, .NET, Swift, and JavaScript. This means that since your front end is in JavaScript and your browser is also a consumer, you can use the same tool with the same approach for the browser, the front end, and the back end. And if in your back end you are using a polyglot approach where you have one microservice with .NET, another one with Java, another one with JavaScript, then you can still use the same approach for validating the whole contracts of your architecture. Finally, Pact comes with a Pact broker. You can think about the Pact broker as a hub where you can publish contracts, tag contracts, and then get contracts by tag or by version or several ways. And finally, it integrates with Archelion Algoron, and this means that you have all the features of Archelion ecosystem plus Pact, and also we provide some features that are not provided by Pact itself. So let's see how to work with Pact. We are going to fix these problems. I have here.
Alex, one question.
Yeah.
Does this relate somehow to Open API specification or Swagger?
Yes and no. I mean that we try to figure out. I mean, the question is if this is something like Swagger. No, Pact is a specification which is they have their own format. The problem you have with Swagger is that you cannot write expectations. So you can say, this is this is going to change in the next version of Swagger. But currently, you cannot put, for example, examples or regular expressions. You cannot say something like, "I want a name, and the name should be this one." You cannot do these kind of things. It's called examples in this argot. I know that in the next version this is going to happen, but currently you have not the same degree for making your contract be really concrete. If you can use Swagger, but then the contract is somehow quite generic, and with this specification, it's more concrete of what you're expecting. This is crimes. I'm going to start with the consumer because we said that we want to use consumer-driven contracts, and I'm going to move this. Yeah, basically I have another branch where I have all the dependencies and so on so far. But that's all. So this is the consumer contracts that now it doesn't compile. The first thing that you need to do is annotate with the runner. And in this case, I'm going to use Archelion Algoron because I want to use some features that are not provided by Pact. But in case of Pact, you should use here the runner of Pact. I mean that in both cases, you need to use a runner. So I use the Archelion runner. Then remember that I said that there is a stub server, and this stub server can be running locally or remote. Remotely can be a Docker host or a server in Australia. And Pact doesn't have any way of be able to deal with this thing. You need to manually set where is the server. But in case of Archelion Algoron, it has some way to detect this and just provide this URL for you. So you don't need to hard code nothing in your code. So you can just annotate a field with stub server, and then here you will have the URL where this stub server is host. Currently, it will be localhost. Then you need to define the expectations. Remember that you have the stub server, and you want to say, when I receive something, I want to return this thing. To do it, you need to create a method which returns request response Pact, which is the expectation. This is at the end is a class. You can put here return group crimes, for example. Probably you will change it to something better. And it receives a Pact DSL with provider, and let's call it builder. That basically this is a DSL for generating all the request response thing. Then I have here this. The first thing that you need to put here is a string, where it is to identify the use case. In this case, is group beeline to get all crimes. The path, which as we said before, is /crimes /group. Method is get.
We respond status 200. The body, I think that it have a body, yes. And then to Pact. And finally, you need to define where, when, who is the provider and who is the consumer for this part of the contract. So and this is done by using the Pact annotation, and where you say the provider, it's crimes, and the consumer is billings. And finally, what we need to do is create a gateway that is able to communicate with this stub server. So I have here a method. This is the web client provided by Vertex to communicate with other HTTP servers. And then the next thing that you need to do is pass here the web client and, of course, the Pact server. Sorry, because this is new crimes gateway. Now, so crimes gateway is just a class which do all this. It's like a web client at the end. That's how you connect to another server. This is something specific to Vertex, but with JXRS you have the same, and with the Spring Boot you have the REST template, and so on and so forth. This is the idea of this. So now I can run this example, and what you're going to see is that the stub server is up. I mean, it's going to start. Then all the expectations are going to be loaded, and then the test will start doing the request response. And notice here that the request is just saying get crimes by billings name. And now it fails. Why? 1990. Okay, why it's not working? Say that it cannot connect to the to where? Why? Well, in this case, what I can do is, just to not lose more time here, is do a git. This is exactly the same, but I changed the branch to these crimes. Okay, this is exactly the same project. And then one thing that I miss is this thing that you need to put, now I get it. You need to put Pact verification to say, I want to verify the crimes part. Yeah, I missed this annotation, and now probably everything is going to work. Yeah, notice that now it's boot up this stub server, which is a Nettie Server. It puts all the expectations, and then I do this assert that, extracting the object, the names, and the wiki are correct. And this generates one file, which is the contract itself, which is that build packs, and this is the real contract. This is how a contract looks like. Instead of writing you manually this, with this test, you're generating the real contract, where you have the consumer, the provider, and all the interactions between this consumer and this provider, which you can see that is the method, the path, and all the response, and the body of the response. So this is the contract. That's fine. Then let's go to the crimes. And in crimes, I have this same thing, right? So if I go to source, here, I'm not going to code because if not, then we're going to get out of time. But basically what you do is like saying, this is a test for the provider of crimes. This is where the folders are stored. By default, well, not by default, but I mean that you can configure Pact to generate this contract in a folder, in a local folder. But you can change this for a Pact broker, for a Git repository, for a Maven artifact, or whatever. So then you do this. Then you have here the target. This target is a web HTTP client that is responsible of reading the contract and start replaying all the request responses. And then I'm using here AssertJ integration. I mean that Archelian algorithm has an AssertJ integration with Pact, so you can do something like assert.target. This target is the real provider with URL. This URL satisfies the contract. So when I'm going to run this, what's going to happen is that the provider is going to boot up. The target is going to start replaying all the requests and response that are in the contract, and then asserting that the response is exactly the same as one defined in the contract. Notice that now it's green, and it says something like verifying Pact between billions and crimes, grew billion to get all crimes, returns a response which has a status 200 OK, and has a matching body OK. So now we know that this provider is compatible with the current consumer. What's happened if I do exactly the same as before? That's saying the user don't know for any reason that wiki is really important, so remove the wiki, and then I run again the test. You're going to see a really big stack trace because it says all the differences and so on. But at the end, the important thing is here when it says grew billions, return response, which has a status code 200, and it's OK, but it says has matching body failed because you've modified the body of the return of the body. So before deploying something to your production environment, you get the failure that someone, by error, has removed something that makes this provider not compatible with your current consumer. And here it says the expectations and what is the difference and so on and so forth. So first of everything, yeah, I mean, this has been a really quick tools in action of Pact, but automate everything. Everything that I've showed you here, like deploying to the cluster, doing the rollback, or running the contract test in the provider and the consumer side, must be done automatically, not manually. Let's bring down conclusions. Just try to avoid end-to-end tests, because it will give you late feedback, because they are really, really slow. Just use contract test in the microservices instead of end-to-end test. Any change on your architecture, it's a deep impact on the changes that you need to do in your end-to-end test. So probably you're going to end up by a flaky test. And finally, it's really difficult to orchestrate end-to-end tests. Nowadays, with microservices, it's really hard. And finally, in the consumer-driven contracts, they fail fast. You've seen that the test runs really, really quick, and it fails just when probably in the commit stage of your CI/CD pipeline. So it means that you get quick feedback that your consumer is not so good. It allows you to do independent deployments, so you can deploy consumer or providers in an isolated way and without having to deploy both of them at the same time. And one of the important things is that improve the communication. Notice that the consumer start writing the contract without knowing if the provider is already developed or not, because you are using a stub. But then you have a contract that you can share with the provider guys. Maybe it's the same team as you, but maybe not. You can share the contract and say, look, this is what you can do. We look good. Yes. Okay, perfect. No. Okay, what we can fix, and so on and so forth. And then the provider can even implement it, run its code against your contract, and if it's green, they know that they have done his work correctly. And if not, they need to check what is the problem. We have 30 seconds, but I will be here after the session, so if there is any question, yep.
How does the contract handle dynamic data? Something that is time-based or tokens? Or
Yeah. Yeah, well, it's timeout, but yeah, the question is about what happened with dynamic data, not the one here. It's everything hard code with GRU, the name, and so on and so forth. Yeah, it has it's really a versatile thing. There is one thing that's called random stuff, which means that it's like a regular expression where you can say something like, here there will be a field called name, and it will be any string, or it will be a field date that will be any date, and it generates a date, but then what you really have is that the matches doesn't take into account this random data. This one thing, and the other thing is that sometimes what you need to do is that the consumer, but it's quite not a very good practice, but sometimes the consumer needs to say to the provider, look, for example, if this is a user, if this provider is a user, and you want to say, I need a user on the provider with name this one and surname this one. So there is also one thing that is called a state, where you can say from the consumer, which is the data that you need in the provider. So you can work with these two approaches for generating, for having dynamic data. All right, thank you very much. And here you can see, this is where you can find the examples.